Hello and good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and for today's video, I am going to discuss the second part of our module, Quarter 3, Week 3, which is all about the midline of a trapezoid. If you're new to my channel, please consider subscribing and hit the notification bell so you'll be updated with my latest videos. Okay, let's now proceed with the definition and theorems for trapezoid. First, let's try to define a trapezoid. Take note, a trapezoid is not a parallelogram. A trapezoid is a quadrilateral with at least one pair of parallel sides. Okay? So in this case, in our figure, we have here quadrilateral ABCD, which is a trapezoid. So here, notice that we have a pair of parallel side, which is this one. So segment AB is parallel to segment DC. Okay? Now, here are the theorem for trapezoid. The median of a trapezoid is parallel to the bases and half the sum of the length of the bases. If you're going to examine in this figure, segment MN is what we call the median of a trapezoid. Okay? Take note that the median or segment MN is parallel to its bases, which are segment AB and segment DC. Now, to solve for the measure or length of segment MN, what we need to do is simply get the sum of the two bases, which is AB and DC. And we're going to get half of it. Okay? That is why it states here that the median is half the sum of the length of the bases. So in this figure, our equation is segment MN is equal to 1/2 the sum of segment AB plus segment BC. So later on, we're going to solve examples on how to find the median of a trapezoid. Now, but before that, let's proceed with the definition of isosceles trapezoid. Okay, when we define isosceles trapezoid, it is a quadrilateral with congruent base angles. And what are those base angles? So here, we have this one. These are base angles. Okay? Another base angle is here. Okay? So these are congruent and also this one. That is why isosceles trapezoid is a quadrilateral with congruent base angles. Now, these are the theorems about isosceles trapezoid. A quadrilateral is an isosceles trapezoid if and only if the legs are congruent. So in this figure, the legs of an isosceles trapezoid is here. So this one and this one. So the legs here are congruent, meaning they are equal in measure. Next, theorem number 2. A quadrilateral is an isosceles trapezoid if and only if the diagonals are congruent. Okay, by examining our figure here, these are the diagonals. So, diagonal, let's say diagonal 1 is congruent to diagonal 2. Okay? So, this one. And for number 3 theorem, a quadrilateral is an isosceles trapezoid if and only if its opposite angles are supplementary. So let's try to take again the word supplementary, meaning the sum of the opposite angles in an isosceles trapezoid is equal to 180. Suppose we name this trapezoid as STAR. Okay? So STAR or quadrilateral STAR is an isosceles trapezoid. If we're going to use theorem number 3, since it states there that opposite angles are supplementary, we can conclude that angle S plus angle A is equal to 180 degrees. Also, take note that angle R plus angle T is equal to 180 degrees also. So these are the theorems about trapezoid and isosceles trapezoid. Now let's try to solve. Okay, let's now find the length of the mid-segment of each trapezoid. In problem number 1, we have the measure of LM, which is equal to 8 yards. Okay, so LM is 8 yards and JK measures 30 yards. Now we're going to find the measure of segment AB. So again, in this figure, segment AB is the mid-segment of the trapezoid. So first is we have to find the equation. So to find the equation of the mid-segment, that is segment AB, is equal to 1/2 the sum of the two bases. So the bases we have there is, we have segment LM plus segment KJ. Okay, now we apply substitution. So to solve for segment AB or the mid-segment, that is 1/2 the length of LM, which is 8, plus the length of JK, which is 30. Okay, so we simplify first those inside the parentheses. That's 1/2 times 8 plus 30, we have 38. Then 1/2 of 38, the measure of segment AB is equal to 19. Okay, so that's how we solve for the mid-segment. So let's try to answer problem number 2. So if we're going to examine, first is what is the formula that we're going to use in order for us to solve for the length of the mid-segment. So here we have XY. Since our XY or segment XY is our median, okay, so that is simply 1/2 the sum of the two bases. We have base number 1 or the upper base, we have segment BU, plus we have lower base or base number 2, which is segment WT. So that's simply 1/2 times VU, which is 22, plus WT, which is 40. So we now have 1/2 times 22 plus 40, that is equal to 62. Then what is 1/2 times 62? Therefore, the measure of segment XY is equal to 31. Okay, so that's how we solve for the median of a trapezoid. Now, in this example, letter B, how about if the missing measure is one of its bases? Okay, how are we going to solve for it? So, in order for us to find the missing measure of each trapezoid, we will still apply the formula in finding the median of a trapezoid. So, what does it mean? If you still remember, the median of a trapezoid is simply, in example number 1, that is segment SR is equal to 1/2 the sum of its bases. We have upper base, which is ML, plus lower base, which is NK. Now, in order for us, since we're looking for the measure of segment KN or NK, so we will plug in these values. So we have SR, which measures 64, is equal to 1/2 times ML, which is 60, plus NK. Okay, so this is the one that we're looking for, the measure of segment NK. So to solve for this, our first step is we will multiply both sides of the equation by 2. So 2 times 64, that is 128, is equal to 2 times 1 divided by 2, so that's cancelled out. What is left is 60 plus NK. And for us to find the measure of nk, we will subtract both sides of the equation by negative 60. Okay? So simplifying the equation, so this will produce 0 pair, and nk is equal to 128 minus 60. The answer is 68. So the measure of segment nk is 68. Okay, now let's proceed with question number 2. So notice in question number 2, we're looking for the measure of side or segment BC, which is the upper base. So again, first is we have to write the mid-segment formula. So here we have FE is equal to 1/2 times the sum of BC plus DA. Okay? Then, again and again, we're going to substitute. So the measure of FE is 45. So that's 45 is equal to 1/2 multiplied to BC. Since we don't have the measure for BC, so that's still BC, plus DA, which is equal to 41. Then, we multiply both sides again, the equation, both sides of the equation by 2. So, 2 times 45, that is 90, is equal to 2 times 1 divided by 2, that is 1, times BC plus 41, we have BC plus 41. Next is we need to subtract both sides of the equation by 41. So, negative 41. So, this produces 0 pair. Then, 90 minus 41, that is 39. So, 39 is equal to BC. Okay, so our answer here, BC is equal to 39 feet. By the way, don't forget to include the units, no? So, in this case, in our answer in number 1, 68 inches ito. Okay? So, that's how we solve for the missing measure of the trapezoid. And now, for our last example, I want you to find the missing measure of the given trapezoid. Okay? So, you use or find first the formula in order for you to find the measure of segment SP, okay, or the base SP. Now, if you know the answer, please comment down your answer in our chat box or in the comment section below. Okay? So, I hope you learned something new, and that ends our lesson for today. Goodbye, class!